Hello everyone, my name is Vaishnavi. Today I am going to explain what is Laplace transform and how to find the Laplace transform of a periodic signal. First of all, we see what is meant by Laplace transform. Laplace transform is the transform that converts the time domain signal into a complex frequency domain, that is S domain. Now this is the signal x of t which is in a time domain. When we apply Laplace transform to this signal, it converts to a complex frequency domain, that is S domain. Mathematical formula to calculate the Laplace transform is Laplace transform of x of t is equals to x of s is equals to integration minus infinity to infinity x of t e raised to minus st dt. Now we see the example of how to calculate the Laplace transform of a periodic signal. So here is the example. Find the Laplace transform of a given function x of t, where x of t is equals to e raised to minus at cos omega naught t plus e raised to minus bt sin omega naught t into u of t. Now we find the Laplace transform of this function. Laplace transform of x of t is equals to x of s is equals to integration minus infinity to infinity x of t e raised to minus st dt. Now we substitute the function x of t into this, so it becomes integration minus infinity to infinity e raised to minus at cos omega naught t plus e raised to minus bt sin omega naught t into u of t e raised to minus st dt. Now we separately integrate this, so it becomes integration minus infinity to infinity e raised to minus at cos omega naught t u of t into e raised to minus st dt plus integration minus infinity to infinity e raised to minus bt sin omega naught t into u of t into e raised to minus st dt. Here the limit of the integration changed from minus infinity to infinity to 0 to infinity, because we have multiplied the u of t to the function e raised to minus at cos omega naught t and e raised to minus bt sin omega naught t. We know that u of t is a step signal which only lies between the 0 to infinity. So the value of u of t is 1 for step signal, that is in between 0 to infinity. So integration limit converts to 0 to infinity e raised to minus at cos omega naught t e raised to minus st dt plus integration 0 to infinity e raised to minus bt sin omega naught t e raised to minus st dt. Now we know that cos omega naught t is also represented as e raised to j omega naught t plus e raised to minus j omega naught t divided by 2, and sin omega naught t is represented as e raised to j omega naught t minus e raised to minus j omega naught t divided by 2j. So we substitute these values into the above equation. So above equation becomes integration 0 to infinity e raised to minus at into e raised to j omega naught t plus e raised to minus j omega naught t divided by 2 into e raised to minus st dt plus integration 0 to infinity e raised to minus bt into e raised to j omega naught t minus e raised to minus j omega naught t divided by 2j into e raised to minus st dt. Now I take 2 outside the integration, so it becomes 1 by 2 integration 0 to infinity. Now I take exponential common, so it becomes e raised to minus 80. Now I multiply e raised to minus 80 inside the bracket, so it becomes e raised to minus 80 e raised to j omega naught t into e raised to minus st plus e raised to minus 80 into e raised to minus j omega naught t into e raised to minus st whole into dt. Plus now I take 2j common outside the integration, so it becomes 1 upon 2j integration 0 to infinity. Now I multiply e raised to minus bt inside the bracket, so it becomes e raised to minus bt e raised to j omega naught t into e raised to minus st minus e raised to minus bt into e raised to j omega naught t into e raised to minus st whole into dt. Now I take exponential outside common from these two integrals, so it becomes 1 upon 2 integration 0 to infinity e raised to minus in bracket a plus s minus j omega naught into t plus e raised to minus in bracket a plus s plus j omega naught into dt plus 1 upon 2j into integration 0 to infinity e raised to minus b plus s minus j omega naught into t minus e raised to minus b plus s plus j omega naught into t to dt. Now I take integration of this, so it becomes half in bracket e raised to minus in bracket a plus s minus j omega naught into t divided by minus of a plus s minus j omega naught plus e raised to minus in bracket a plus s plus j omega naught divided by minus of a plus s plus j omega naught. Sorry, here t is remaining. It becomes from 0 to infinity plus 1 upon 2j e raised to minus b plus s minus j omega naught into t divided by minus b plus s minus j omega naught minus e raised to minus b plus s plus j omega naught into t divided by minus of b plus s plus j omega naught from 0 to infinity. Now I substitute the upper limit first and then lower limit. So substituting upper limit, it becomes e raised to minus infinity divided by minus of a plus s minus j omega naught plus e raised to minus of a plus s plus j omega naught into infinity divided by minus of a plus s plus j omega naught. Now I substitute the lower limit e raised to 0 divided by minus of a plus s minus j omega naught. So this minus e raised to 0 divided by minus of a plus s plus j omega. Now I substitute the limits into the second bracket, so it becomes plus 1 upon 2j e raised to minus infinity minus of b plus s minus j omega naught minus e raised to minus infinity divided by minus of b plus s plus j omega naught. Now I substitute lower limit minus e raised to 0 divided by minus of b plus s minus j omega naught. Minus minus it becomes plus e raised to 0 divided by minus of b plus s plus j omega naught. Now I simplify this, so it becomes half e raised to minus infinity 0, so this terms becomes 0, the second term also 0, minus e raised to 0 1, so 1, this minus and this minus becomes plus, so plus 1 upon a plus s minus j omega naught. This minus and this minus becomes plus e raised to 0 1 divided by a plus s plus j omega naught. In second bracket plus 1 upon 2j into e raised to minus infinity 0 minus e raised to minus infinity 0. This minus and minus becomes plus e raised to 0 1 divided by b plus s minus j omega naught. This plus this minus becomes minus e raised to 0 1 divided by b plus s plus j omega naught. Now I further simplify, so it becomes 1 upon 2 in bracket 1, cross multiplying these two terms, so it becomes a plus s plus j omega naught plus a plus s plus j omega naught divided by a plus s whole square minus j square omega naught square plus 1 upon 2j into cross multiplying these two terms, it becomes b plus s plus j omega naught minus b minus s plus j omega naught divided by b plus s whole square minus j square omega naught square. So it becomes half in bracket 2 in bracket a plus s j omega naught minus j omega naught get cancelled divided by a plus s whole square. The value of the j square is minus 1, so it becomes plus omega naught square plus 1 upon 2j into b plus s get cancelled, so it becomes 2j omega naught divided by b plus s whole square minus this j square value is minus 1, so it becomes plus omega naught square. Now this 2 get cancelled and 2j get cancelled, so it becomes a plus s divided by a plus s whole square into omega naught square plus omega naught divided by b plus s whole square plus omega naught square. So x of s, this is the final answer of our Laplace transform. In this way, we can solve the Laplace transform of a periodic signal. Thank you for listening.